With the 2021 Formula One World Championship set to see lights out in 3 weeks' time, the entire F1 fan base is prepping their fanware and gearing up to follow what could potentially be the longest F1 season for this decade. We have 2 new tracks added this season relative to last year, and given very similar performance expectations from the cars this year, albeit slightly less downforce and rear-end grip, it's fairly easy to predict the general lap times of these cars. However, in order to convert these ballpark figures into more robust values, we'll need to accurately observe downforce effects from these new underbody designs. Now, the Circuit de Catalunya at Montmeló has been host to the Spanish Grand Prix for the past 3 decades and notably has been an extensively used venue for F1 preseason tests for many years. The nature of this track gives a well-rounded reference for performance for Formula One cars. This year, however, the pandemic as we know it has pitched a curveball that F1 has to adapt to smash preseason testing out of the park, or so we hope. The preseason tests have been scheduled for the second week of March starting on the 12th, just a couple of weeks before the season opener held at the same location as the tests, the Bahrain International Circuit. Having done detailed analysis of these 2 tracks for other lower-end open-wheeled race cars in the past, I can already tell that there's a stark difference in tire energy cycles and general tire consumption rates between the 2 tracks. So let's first dive into a more subjective analysis of each track and determine the implications of running these preliminary tests at Bahrain. Now, the Circuit de Catalunya is a relatively hilly track tallying at a length of 4.7 kilometers with last year's pole lap set by Hamilton at 85.5 seconds. This gives an average hot lap speed of 197 kilometers per hour. As you approach the first set of corners, which are a sequence of a fast left and right, the drivers go heavy on the brakes. Now these corners are uphill and tend to moderate their energy levels with more mechanical load on the rear tires. Lack of sufficient throttle through this section can lead to understeer. Now the cars then power on to a relatively flat, high-speed turn 3. The lateral saturation of the tires reached their highest point at the apex of this corner and is definitely a benchmark for the downforce levels these cars can pull off during this year, given Catalunya is a track with a high downforce preset to start with. Turn 4 is a high-energy corner as well. However, the ratio of lateral to longitudinal saturation is slightly lower due to the trail-braking nature to attack the entry of these corners. Turn 5 is a generic slow-speed downhill left-hander with not much aero influence. As we head downhill through Turn 6, we gear up for a set of corners where mechanical balance is paramount. Turn 7 and 8 are a pair of corners forming a medium-speed uphill chicane where cars can potentially bottom out. The cars fly down through Turn 9, which is another high-speed right-hander with maximum lateral saturation and is usually another key point of interest for the teams in their aerodynamic analysis of the circuit. The final section of the track is highly technical and is predominantly a low-energy sequence of chicanes. Turn 13 is a moderately high-speed right-hander despite its tight radius as the track dips down into the final chicane sequence of the circuit. All in all, the circuit provides a wide range of corners, chicanes and straights, the quintessential challenging F1 track with high tire wear over the course of the relatively hot track temperatures usually seen in the Spanish GP in the summer. Now, on the flip side, Bahrain offers a completely different combination of corners. We first fly down the main straight to enter the heaviest braking zone on the circuit. Longitudinal saturation levels peak at this point as the drivers trail brake into turns 1, 2 and 3, serving as a technical start to this layout. Getting a good exit off turn 3 is paramount to maximizing straight line speed into the second braking zone on the circuit at turn 4. The corner itself is not exactly spectacular, but the track more than the curbs themselves tends to be very dusty due to the off-cambered shape on the tarmac here, which is another variable that throws off the dynamic grip of the tires. Turns 5, 6 and 7 are the best chances the tires have to reach high lateral saturation and are the key performance zones for aerodynamics in this circuit. More so because the cars tend to naturally accelerate due to the downhill attitude of the track at this point. Now turn 8 is once again a cambered corner and is extremely tight as it exits upwards. The cars then accelerate over a small hill and start braking at the crest through a tricky turn 9 into a hairpin at turn 10. Now the rear left is prone to losing grip after the crest of this downhill right-hander, and then the front left can potentially lock into turn 10. This section is potentially the tire-wearing poltergeist in this mechanical section of the track. Now, turn 11 is once again a high downforce lateral saturating corner and keeps the cars planted as the track elevates into a high-speed turn 12. The cars then start braking after the crest beyond turn 12 and carefully trail brake into turn 13 to gear up for a long back straight. The final braking zone of the lap is not as severe as the first one, but still involves gradual trail braking through turns 14 and 15 to ultimately complete a lap around this relatively fast-paced circuit. The circuit is 5.4 kilometers long and a qualifying lap time of approximately 87 seconds was set last year. So this gives an average speed of 223 kilometers per hour, which is significantly higher than that in Catalonia. After some rough approximations, I have concluded upon the following distributions for the percentage of time spent on straights, high speed and low speed corners for both circuits. In Bahrain, you spend roughly 15% more time on straights as compared to Catalonia, which already proves that the ideal downforce and parasitic drag value should be kept quite low in Bahrain. Catalonia also spends more time in high speed and technical sections, which shows that a nearly neutral mechanical balance and high downforce configuration is needed relative to Bahrain. This can be further elucidated by looking at the ballpark setup distributions for both tracks. The aerodynamic balance is more front biased in the case of Bahrain due to a lack in rear wing angle as required by the low drag necessities of the track. Something else to note is that Catalonia really taxes tire life and requires a lot of tire conservation and more dynamic strategy calls to maintain optimal grip levels, further supported by Sebastian Vettel's radio messages from last year's Spanish GP. Having said all of this, it's unsurprising to see that the tire compound choices offered by Pirelli for both these tracks are not the same. The Bahrain GP uses Pirelli compounds C2 through C4 for the race, with higher numbered compounds being softer. Now this works better for cooler, low energy tracks as seen in the nighttime Bahrain race. If softer compounds were to run in hot conditions, the tire wear rates would be phenomenal and not in a good way either. So, at the end of the day, Bahrain will definitely get those motors running, but it's certainly not going to be the team's best reference for downforce and oversteer effects that these new underbody designs will bring. So, what is this season going to deliver? Will Lewis Hamilton become an 8-time world driver champion? Is Bottas going to have a shot at it, or is Verstappen going to be the wildcard challenger? We'll need to wait and see, for Murphy's Law is always on the prowl. Thank you so much for watching. Stay tuned for the next episode of GPS where we look at preseason testing in detail. Until then, take care and stay safe. This is Saidat signing off.